All right, so let's just talk f of x equals log base 2 of x. What does the graph look like? Well, first of all, we could point out here that one thing we note is because of the things we know about the logarithm, what can't x be? X can't be negative. X can't be 0. X has to be positive, doesn't it? If there's no shifting or anything like that, x has to be a positive number. All right, so when we go to our table over here, when we're listing values out for x, is there any reason to put negative numbers? No. X definitely, x can't be negative here. So I'm not going to start out at -2, -1, 0 even, because x can't be any of those. Okay? Those are out. So I'm going to start, next logical place to start then would be 1 maybe. So we'll do x as 1, then 2, then we'll go from there. All right. So if x is 1, what's the y value? Wouldn't the y value be the log base 2 of 1? 0. Is everybody okay with that? That would be 0? Why is it 0? It's 2 to what power gives me 1, isn't it? And so that needs to be 0. All right, what about 2? Log base 2 of 2. Well, that's 2 to what power gives me 2, right? This to what power gives me this? That'd be 1. Okay? So we've got two good numbers there. We could go to 3. 3 would be okay, but why would 3 not be the wisest choice right now anyway? 3 is not going to be a nice power of 2, is it? What I want for the x's here are nice powers of the base. So if I was doing log base 3, I'd want nice powers of 3. If it was log base 13, I'd want nice powers of 13. This one's base 2, so I want nice powers of 2. 4 is a nice power of 2, so I'm going to go with 4. What would be another nice power of 2? 8. 8 is another power of 2. 16 is another power of 2. So let's go with those for right now. All right, and so if we do that, things work out nicely because this is saying 2 to what power gives me 4. Well, that would be 2. 2 squared. Log base 2 of 8. Well, that's 2 to what power gives me 8. So that's 3. And this would be log base 2 of 16 for the y value. And so that's 2 to what power is 16. So that is 4. So we've chosen wisely here, haven't we? There's a little bit more, though, to go here. So all right, so at 1 we've got 0. 2 I've got 1. 3 I've got, I don't know. 4 I've got 2. And then jump to 8. At 8 I'm at 3. And then at 16 I'm at 4. So it's on the rise over there. It's one of those increasing deals, isn't it? It's not rising nearly as fast as some things we've seen, but yeah, it's just going to continue to rise ever so slightly as you go out there. Now we've already said there's nothing on this side. There'd be nothing on this side, right? Why not? We can't have x be negative, right? So x is negative over here, so on this graph, there's nothing on this side of this graph. It's kind of like the square root in that regard. You don't have anything with your square root graph. You don't have anything on the left side of the graph, left of the y-axis there. But you might notice here I'm missing one piece of this graph, because can x be in here? Between 0 and 1? Yeah. X can be between 0 and 1 because those are positive numbers. Well, let's explore that a little bit in there. We won't have to necessarily do this each and every time, but just note what's going to happen here. Well, cut to the chase here. Let's look at the values of x as 1/2, 1/4, and 1/8. If x is 1/2, I'm looking at the log base 2 of 1/2. What is that going to be? What is the log base 2 of 1/2 going to be? -1. You're right. It's going to be -1. Because it's -1. 2 to what power gives me a half? Well, that's the -1 power. Log base 2 of 1/4, kind of going in order here, wouldn't that be -2? 2 squared gives me 4, so -2 would give me 1/4, -2 power. And then guess what? Log base 2 of 1/8, -3. 2 to what power gives me 1/8? Be -3, wouldn't it? With me? All right. So at 1/2, I'm at -1. Then at 1/4, I'm at -2. At 1/8, which is getting closer in there to the y-axis, I'm at -3. You see what's going to happen here? Isn't it just going to keep dropping? As I get closer there to x is 0, the values just keep dropping as far as the y values go. At 1/2, it goes to -1. At 1/4, it goes to -2. At 1/8, it goes to -3, -4. At 1/16, it would be -4. So the values just keep dropping as I get closer and closer to 0. X is 0. Now, will I ever cross x is 0? I won't ever cross that line, will I? X is 0 line. So it's getting closer and closer to x is 0, but it doesn't ever cross x equals 0. What do we call that sort of scenario? We're getting closer and closer to this line, but so it's dropping, but it's never crossing that line. Vertical asymptote. Okay. There's a vertical asymptote. And in this case, it's x equals 0. We can't cross that line. For one thing, x has to be greater than 0, so we can't cross that line. This is the reason in this case we have that. Now this one's different from the vertical asymptotes before on the rational functions, because on the rational functions one side went down and then the other side either went up or down, but on this one it's just that. Now, what shape is that? Does that remind you of anything? It's a hockey stick. However, it's a hockey stick on its side, right? And that's the inverse relationship at work there. You know, the exponentials are the hockey stick, right side up, right or left one. You know, that's an exponential. F of x equals 2 to the x. Well, the logarithms, since they're inverse, this is what happens on the graph of an inverse. It'll kind of rotate it around this. There's more to it than that, but for now, yeah, it's kind of the rotated hockey stick. It's hockey stick on its side. Now, whereas the exponentials have a horizontal asymptote, these logarithm graphs have a vertical asymptote. They don't have a horizontal asymptote. They have a vertical asymptote. And unless there's shifts in there, the vertical asymptote will be at 0 for all such logarithms. Okay? All right, so let's do this one. All right, so what does f of x equals log base 8 of x, what does it look like? Well, table, here we go. Start with 1 because we can't do negatives, so we're going to start with 1. What'll be next, though? We can do 2. Okay, let's throw that one in. All right, 2. Really, though, what am I focusing on? I've got a base of 8. So, what x values? That are powers of 8, right? Powers of 8. 1, 2 is, but that's just a good one to throw at you here. How about 8? What else? What's another power of 8? 64? Yeah, it's going to get big numbers pretty quick here for the x values to get powers of 8. What's the next power of 8? 512? Just powers of 8. 8 squared, 8 to the third. If I do that, it works out really nicely. This would be then the y value is log base, plug in x to be 1, so it'd be the y value would be log base 8 of 1. And so 8 to what power gives me 1? That's 0. Somebody said 2, so I put it up here. That one does turn out to be pretty nice. What power of 8 gives me 2? Think of that one? How is 8 related to 2? How do I get 2 out of 8 as far as powers or roots? Isn't that the cube root? Cube root? Cube root now. So that's 8 to the 1/3 power is 2. So what's the logarithm base 8 of 2? 1/3. Yeah. All right, then log base 8 of 8. This one's back to the easy ones. What is that one? That would be 1. Log base 8 of 64. That would be 2. Log base 8 of 512. That would be 3. With me? 8 to the third gives me 512. 8 squared gives me 64. All right. So we got 1 is 0. 2 is a third. Then we jump all the way out to 8 is 1. Then I have to go out to 64. So I'm going to fudge a little bit because this is not, yeah, it'd be way over there. To get to 2, and then 512, way off the board there, would be the 3. All right, so we get these. Moving up there. But that's not the full story. What else I've got? I've got a little more because what is this right here? I've got the vertical asymptote, just like with the first one we did, log base 2. I've got a vertical asymptote at x equals 0, the y-axis. And it's a vertical asymptote where it goes down as we go towards that vertical asymptote. So that's the full deal. Log base 8 of x, f of x. Question? Got it? All right. One other note here then. F of x equals log base 2 of x plus 3. Do this one by noting this. This graph has a shift put on it. And what's the shift that's been put on it? Plus 3 on the inside, 3 to the left. Three to the left. So, among other things, where does that put then, instead of the vertical asymptote being 0, if I go everything is 3 to the left, doesn't that put the vertical asymptote at Negative 3. Okay? All right, and so here's the other thing. You know, I've got bases 2. Let me do this. All right, so I've got bases 2. And so my powers of 2, 1, 2, 4, 8. However, I've shifted everything 3 to the left, which means the x values that I would want are shifted 3 to the left. And so instead of 1, if I shift that 3 to the left, what does that give me? Left 3 means subtract 3. Negative 2. 3 to the left on 2, subtract 3, gives me negative 1. So I'm picking x values here that are powers of 2, but shifted 3 to the left or subtracted 3. Because that's going to give me nice powers of 2 when I plug them in. If I plug in x to be negative 2, doesn't that give me log base 2 of 1, which is a nice power of 2? It's 0. Here, this gives me log base 2 of negative 1 plus 3, which is log base 2 of 2, which is 1. Log base 2 of 1 plus 3 gives me log base 2 of 4, which is a nice power of 2. So the idea is to get these numbers to be nice powers of 2, and so I have to shift these numbers 3 to the left. So anyway, just something to think. At negative 2, I'm at 0. At negative 1, I'm at 1. At positive 1, I'm at 2. And then at positive 5, I'm at 3. Yeah, there you go. All right, so anyway, throw all that at you. Okay.